run the slideshows. We're not going back and forth. So we are really pleased and honored, honestly, to have this excellent panel. We have Dr. Wendy Gabriel, who I'm really lucky to work with at the Northeast Fisheries Science Center. She's our division chief for our population and ecosystems monitoring and assessment division. She's going to provide sort of an overview of wind energy impacts and effects on federal fisheries surveys, and notably what the science is saying about impacts on our surveys and what we can do about them. And we have Captain Dave Gaithel, who is captain of the fishing trawler, the Ellen Diane, out of New Hampshire. Dave, if you don't know him, is an amazing fisherman, a font of information and knowledge of the fisheries in New England. He has participated in the management process, he's participated in the fishery, and he's participated in the collaborative fisheries science and research process through his role in the Northeast Trawl Advisory Panel, which is a bi-council advisory panel that helps us as the Science Center understand and improve our federal fisheries bottom trawl survey. And he's been a long time participant in our research study fleet. So thank you, Dave, for joining us. And we have another Dave, Dr. Dave Rudders, who's Associate Director, the Virginia Institute of Marine Science in their Fisheries Science and Marine Advisory Program. And Dr. Rudders will talk about offshore wind energy effects on many of the cooperative scallop survey operations that VIMS and Dave have been involved in. I have just one or two opening slides, and then I will run our slides for our presenters. So let me share my screen and see if I can do this correctly. So I have, okay, where is that? This is the one I want to share. And I can't tell whether it's working or not. So if you could just indicate, Pat or Maggie, that you can see a slide that says fisheries, and I see a thumb. I can see the shark, so we'll be watching for that. So this panel is about fisheries independent surveys and about the science to address impacts and effects of offshore wind on our surveys. Let's see if I can. So we have fisheries independent surveys in our region, fortunately, that have gone on for decades. I mean, this is one of the great news about addressing the fisheries issues in our region relative to wind is that we have some of the richest, not only some of the richest grounds in terms of fisheries, in terms of value and volume of catch, globally, with massive fisheries, but massive amounts of data from fisheries independent surveys, all geared to really understanding this really difficult to understand ecosystem. And this is just a quick slide of some of the data that's obtained through our bottom trawl surveys, our scallop, dredge, and integrated benthic surveys, our clam surveys, and our ecosystem monitoring surveys that take place across our shelf breaks. So we are really fortunate to be working in a part of the world where, although we don't understand everything, we have invested over decades and developed time series across this large marine ecosystem boundary. See, this is not. And so we have many different fisheries independent surveys, and that contribute large amounts of data. These surveys will be disrupted by offshore wind, and I'm using the term disrupted in the broad definition, right? There's risks associated with impacts to these surveys, but there's also opportunities associated with solving those problems from offshore wind in terms of the disruption on these surveys. But there's also a lot at risk because these surveys, whether it's our fisheries resource surveys or our protected species surveys, really underlie, along with our fisheries dependent data collections, underpin a $14 billion a year fishery in terms of the value contributed to US GDP. So with that, we're going to go to our first speaker to dig a little bit more into this topic, and that's Wendy Gabriel. So Wendy, if you unmute yourself, I will shift to your presentation.
Oh, okay, can you hear me?
I can hear you.
Yep, you sound good.
Okay, great. I'll be waiting for the slides.
Can you see your slide?
Nope. I'm viewing your screen and I don't see my slides.
And I can see, I mean, your slides I can see fine.
You can see.
You may just need to share the new window that has Wendy's slides in it.
Share the new window, okay.
If it's open in a different window.
I thought this was going to be easier.
Okay, there we go.
Looks good. Thanks very much. Andy gave kind of a lead in terms of what our fishery independent data monitoring program does. It's different from wind energy area monitoring because it's designed for stock assessment and management purposes. And from that perspective, we want to look at the stock over the whole area, including both inside and outside wind energy areas. And then use standardized approaches so that when the changes that we see are attributable to stock abundance changes, not differences in gear or operational changes. We take these survey indices and combine them with catch data, various elements of the fishery dependent data that we heard about in the previous session, combine them in stock assessment models of varying degrees of complexity to estimate spawning stock biomass and fishing mortality rates, which then serve as the basis for fishery management recommendations. So we want to maintain this information flow over time so that we can inform our stock assessments and our management recommendations. Next slide, please. So back in 2018, we started to realize there were going to be some pretty significant implications of wind energy development areas on our surveys. One significant component was the curtailment of vessel access. In the case of the Henry Bigelow, which is our bottom trawl survey vessel, they've adopted a policy of maintaining a distance of greater than 1 kilometer from the Block Island turbines. And in any wind, so in wind energy area where the turbines are spaced at about 1 kilometer apart, we wouldn't be able to sample, although it's up to the captain to decide with respect to safety whether to sample there or not. We have other large vessels that are used in our surf clam and ocean quahog survey that also may be subject to those same constraints, and potentially also our scallop survey vessel. The untrawlable bottom isn't just necessarily due to the effects of turbines. There's also the effect potentially of cabling and the attraction of recreational and fixed area effort. At the same time, we have a historical stratified random survey design implemented here since the 1960s. And when you include the effects of wind turbine areas on random sampling, you can't sample randomly in areas that have turbines in them. So that means that we're not going to be able to continue that in these areas as we have historically. And this is going to affect just about every survey because a lot of our clam, quahog, and scallop surveys have either based on stratified random designs or have significant components that are stratified random, and again, large vessels. So this is a pretty universal effect. Next slide, please. So here's an example of the overlay of wind energy areas based on projections in not really projections, but based on leased and planned areas as of 2018. And those yellow areas overlay the boundaries of our survey strata. Next slide, please. And you can see, depending on the survey stratum, that we lose up to 37% in one strata. Next slide, please. 32%, next slide. 44% of one stratum, next slide. 32% of that stratum, next slide. And then a very small inchcore stratum where we lose 60% of the area. Next slide. And this happens for our scallop survey as well. Next slide, our surf clam survey. Next slide. And our ocean quahog survey. Next slide. And so anyway, just to summarize, we could go from anywhere to up to 60% of a trawl survey stratum, up to 20% of a sea scallop stratum, and between 7 and 11% maximum of our surf clam and quahog stratum. Those are larger strata, so they're smaller percentages. Next slide, please. And this is just, I think, the beginning. We expect that these areas will expand in Maine and New Hampshire and Massachusetts as time goes on. And as moored turbines come online, that some of this area will also expand into those deeper strata. So we don't really know exactly how big those areas are eventually going to be and how fast they're going to be occupied. Next slide, please. So what are we going to do about this? First off, what's the effect that the wind energy areas are going to have on survey operations and data streams? And just as for example, if we don't include the wind energy areas in our historical survey indices, what effects does that have? And this depends on whether the wind energy area is a hotspot for that species or it's rarely prime habitat for that species. The complicating factor is, in the case of bottom trawl species, we need to look at this for over 40 assessed stocks. Next slide, please. So the exciting part here is looking at optimal combinations of alternative sampling methodologies and statistical designs for wind energy areas. So in terms of methodologies, we know we're going to have to replace or augment some based on the constraints we talked about earlier in terms of placement, cabling. And from that perspective, we'll be talking with Captain Gaithel and his colleagues to figure out how much of our traditional capture methodology would be capable of being implemented there. Can we continue to trawl? What's the largest safe functional vessel we could put in there? We need to modify our nets. What do we have for feasible tow durations between cables? We have the same kind of questions for our dredge surveys. We know that this isn't going to be possible in areas right next to turbines. So is there a different capture fishery that we could use, like a jig or other fixed gear? Or a variety of those non-capture sampling regimes that Mike Jack talked about earlier this morning, combinations of optical surveys, acoustic surveys, eDNA surveys, and then the array of alternative platforms that they could be mounted on, unmanned gliders, sail drones, AUVs, fixed turbine attachments. Also, we have a series of different statistical models we need to look at. How do we combine the random stratified survey design with our potentially a fixed design in that area or transect surveys? So that's a traditional estimator-based approach, or do we use a model-based approach, say a VAST model of a vector autoregressive spatiotemporal model? Which one of these has optimal combinations of low variance and low bias? And what kind of constraints are there in terms of species catchability and size selectivity? So in case I'm going to run out of time to get to the very end, this part of the step is, these first two steps are being evaluated through an interagency agreement that we've just implemented with BOEM. And in that interagency agreement, we're going to be developing some, next slide, please. We're going to be developing a design for a simulation to compare these different combinations of models and methods. So at the design phase, we'd be looking at the candidate sampling methods and surveys to be survey designs to be evaluated, and characterizing the structure of the simulation model. So that's basically the design phase, and also looking back at step one on the effect that these energies have, wind energies areas will have on our status quo operations. So that's the first part of the step here, is to design the simulation. Then further on, we're going to execute this simulation bake-off in something similar to an ocean system simulation experiment, and then develop an optimal solution. Next slide, please. Then we need to make sure that we can integrate these data from wind energy areas into our ongoing survey data streams. And again, as I mentioned, we need to picture over the entire stock range, because we need to interpret the changes that we see in the wind energy areas combined with the rest of the stock energy areas. So if it increases in a wind energy area, is that a stock-wide phenomenon, say due to increased recruitment? Is it due to a stock-wide phenomenon, say a climate change effect that is changing the distribution everywhere? Or is it a local distribution effect, say, for example, movement from to a preferred habitat inside a wind energy area? And the converse is true for decreases. So all of these potential mechanisms could be in play over the 30-year time frame that we expect these wind energy areas to be in place. Next slide, please. For example, black sea bass, if we saw a decrease in the trawlable area, would this be a decline in the stock or a shift to new habitat? Next slide, please. So this emphasizes the importance of calibration. We want to quantify those differences in sampling methodologies so that we can compare and integrate the wind energy area observations with our ongoing and historical observations. In some cases, this is a simple comparison of the catch rate. For example, a small scallop dredge versus a large one. Vessel gear calibrations for trawl surveys we've had experience with, and the part of the complexity there is developing scalers between different gear and vessel configurations that have differences by individual species, and we're looking at up to 40 species. In some cases too, we've got things like jigs or long lines that are not directly comparable to trawls. Next step. So we want to find as a gap there some provisional indices while we try and bridge this gap through the development of new methodologies and calibrations, and then spin the program up. Next step. Next slide, please. Then we want to actually do it. And we'll do it for 30 years. Next slide. Next slide, please. And as Mike Jeck mentioned too, we need to have data processing and analysis development, database structure development throughout the process. And this is actually probably one of the first steps rather than the last one. Next slide, please. Okay, we can skip that. We're looking at step 1 and starting step 2 with BOEM. Next slide, we're going to be looking at 2 workshops to develop that simulation. Next stop. Next slide, please. And specify what has to be in there. Then we have to, so that's just the design. Next slide, please. And then we'll just have to build the model, come up with the solution in terms of methodologies and sampling designs. Next. And do it. We have something similar underway for the integrated benthic survey for scallops. We're at the internal planning stage for that. Next slide, please. And then we also need to locate the time and the resources to design and execute these new surveys. That includes peer review at all stages in terms of design, the calibration, and the implementation. And we look forward to partnering with Rosa and other developers as these plans move forward. And I think that should wrap it up. I'm sorry, I went a little bit over there.
And Andy, it's been about 16 minutes, just to let you know.
Thank you, Wendy. Let me see if I can do this. I might have to stop sharing and then reshare again. So get rid of this. Dave Gaethel, while I have your slides, Dave, if that's okay for me to advance them for you. Are you able to unmute yourself and join us?
Yes, and if you want, my wife can run the slideshow if you share your screen. It's up to you.
I've got it. I think it's working right now.
There we go. Hey, Dave, over to you. Thanks for joining us. Appreciate it.
Okay. Well, thank you. I figured people might rather look at fish than watch me talk. So anyway, fisheries law, the Magnuson-Stevens Act requires science-based management. So what can we do when the principal component of the science, in this case, the trawl survey, cannot be completed across a broad geographical range? Fishermen worry they will be penalized twice, once from closure of the area to fishing, and twice because missed survey tolls result in greater scientific uncertainty, which in Magnuson translates to lower quotas with which to feed the American public. Cooperative research is one way to fill this gap, I believe. For those of you who are not familiar with cooperative research, it is scientists and fishermen working collaboratively to solve a scientific question from design of the study to publishing peer-reviewed final reports. it is far more than just chartering a vessel. So how could this be accomplished? Well, fishermen have a wide array of vessels which could operate inside a wind array where the large government vessels cannot operate. Some examples of possible gears that could be deployed include a small vessel deploying a trawl at fixed stations within the array, panels of multiple mesh-sized gill nets to sample fish, long lines deployed in hard bottoms where trawls cannot be towed, small scallop dredges or drop cameras or towed cameras to identify multiple species, ventless lobster trap surveys, plankton tows, and panel studies for invertebrates that attach to substrates. And that's not an all-inclusive list, but that's to give you an idea of things we could do. With all the above mentioned, two things will need to occur. They will have to be calibrated against the trawl survey, and assessment scientists will need to find acceptable means of integrating these substitute methods into the models. This work needs to begin now, before construction, for two reasons, both to establish a baseline and to give all the gears unfettered access to the strata. As Wendy said, we've got to calibrate all this gear, and that takes time. One should remember that the trawl survey measures stock-wide relative abundance, and the wind farm areas are a subset of that regional measurement. So we're looking at two somewhat separate problems here, but they ultimately combine to the same thing. And this is not a trivial exercise. I don't want people to think that this is something we can snap our fingers and in 6 months it'll be done. It'll require a long-term commitment of substantial financial and human resources for 30 or more years. And finally, we need to discuss the energy companies' commitments to collecting scientific information. The companies are interested in collecting data, but their focus is in showing the effects of the wind array on living marine resources. Their hope is to be able to state they have no effect, or better yet, a positive effect on the environment. This is not a bad thing, but it is not the same as collection of data that we described above. The fishery independent data I have described is necessary to solve an avoidable problem of poor management decisions made because the collection of adequate scientific information in vital geographical areas is not accomplished. It is incumbent on the wind industry to finance the collection of this information so that the fishermen can continue to sustainably feed the American public. And I thank you for your time. And we'll answer any questions people have.
Thank you, Dave. Great words, and also great pictures. Really appreciate it. And what we'll do is we'll go through the rest of the panel, then come back and take questions for Ron.
Okay.
All right. Dr. Rudders, thank you, Dave. That was awesome. I think that I have figured this out.
Yep, we can see it. Great.
Perfect. Welcome aboard, Dave.
Great, thank you. Thank you, Andy, and good afternoon, everyone. Greetings from Virginia, where it doesn't seem to be snowing. I'm not sure if you have snow up there, but it's not too bad down here. Well, you know, first of all, thank you for the introduction. My name's Dave Rudders. I'm from the Virginia Institute of Marine Science, and you know, a lot of the issues that I wanted to talk about have been covered by Dr. Gabriel and Mr. Gaethel, and so hopefully I can add a little bit of my perspective over the work that I've done for the last 20 years, mostly with cooperative research, and I think that will add another element to this conversation that might potentially be helpful for moving forward with some strategies and some plans to be able to provide fishery independent data in the context of offshore wind development. So next slide, please. So this presentation is going to be pretty short and sweet, but I did want to just give you a little bit of my perspective. And so if you think about the scallop experience, these fishery independent surveys, they provide a wealth of information on a number of spatial and temporal scales. And really, if we think about the data that we collect on an annual basis, it's used to evaluate stock status, inform quota setting for subsequent years. But one of the real powers of the data that's collected is it provides longer term insights into both the stock and the environment in which they live in. And so I think the Scallop RSA program, represents a somewhat unique mechanism to holistically support this effort. And, I don't know if we will characterize it as a model, but there may be some aspects that are a model, but I think you can view it as an experience as well. So if you look at this map to the right, that is a depiction of the coverage in 2020 of all the different Scallop surveys, minus the federal survey, which was not able to be completed, but all the RSA funded surveys that were able to look at the Scallop resource in 2020. And so you can see, and I think that really gets back to what the previous two speakers talked about is, we're going to need an integrated approach. And if you look at how we have looked at the Scallop resource, there's dredge tows, there's a hab cam element, there's a drop cam element as well. So all those things kind of fit together to give us a picture of the resource. I think that's going to be especially helpful as we move forward, thinking about how to conduct fishery independent work in the context of wind development. Next slide. So, I think one of the big picture things that I think about a lot as we are tasked to kind of read the tea leaves moving forward and also look backward at the data that we've collected for the last 2 decades is, the footprint of this resource and all the resources that we're dealing with is changing. It's a function of warming oceans, changing oceanography, diseases, parasites, and more recently offshore wind development. And so I think the fishery independent surveys are nice and critical in the sense that they provide one lens to view these changes on a consistent basis across time. And if you look at this figure, this is graciously provided by Kevin Stokesbury from one of his recent papers on this topic. It's an amalgam of kind of the spatial footprint of the Scallop resource over the last roughly 2 decades. And if you think about kind of the vast area that this resource covers, and you look at some of the potential overlap with wind development, it is potentially going to be pretty significant, and in areas that are traditional Scallop areas. And I know we've talked about a lot about this overlap and what those impacts might be on the fishery, but as Dr. Gabriel said, it's going to have a big impact on how we think about and conduct our surveys as well. So next slide, please. And so when I was thinking about what I was going to say today over the past weekend, I happened upon my son out in the garage trying to join 2 pieces of wood together by hammering a screw into the wood. And so at first, my first thought was, oh my goodness, I have failed you. But second thought, it got me thinking about, sometimes there's right tools for the job. And sometimes you need to use different tools for the job. And sometimes you need to create new tools. And so really, if you think about fishery independent surveys, we like to have a continuity of information. We like to have surveys that are conducted the same over time and space to give us an idea. But that doesn't necessarily mean doing the same thing. And so I think the Scallop RSA program provides a good way to reflect on how we can think differently and more broadly about these potential solutions. If you look at these pictures, there was the drop camera that came out of Kevin Stokesbury's lab at SMAS that was developed in the context of the RSA program. And then on the far right, there was the HabCam system, the towed optical system, which was also developed within that model. And what it really highlights to me is if there is an impetus, if there is desire and need to come up with different solutions to approach a problem, it's just going to take a problem, and it's going to take innovation, and it's going to take resources. And so I think we are looking at a very similar situation here. If there's a commitment to look at these surveys as an important component of how we think about marine resources, then we're going to need to invest time. We're going to need to engage people that can innovate to come up with solutions to approach that. So next slide. So this is my final slide, and just kind of some unifying themes. I think fishery independent surveys provide one perspective into really a broad range of species specific and ecosystem-wide processes. It's not the only source of information, but I think it is a pretty important one. And the system is really dynamic. We know that. We know it's changing at a rate that we haven't seen in modern history. And again, these surveys provide a role in characterizing these changes. And so offshore wind development may represent one challenge that we need to think about and how we want to hurdle that and still be able to understand the stock specific and ecosystem wide situation as it moves forward into the future. And so I'm kind of a glass half full guy. I think these challenges are challenges for sure, but they also represent an opportunity to innovate and to support a continuity of this information as we move forward. And really, this innovation will likely require a collective will from all parties involved, and also some pretty significant investment. Thank you.
Great, thank you. Andy, do we have others or are we ready for questions?
I think we're ready for questions, and I'll stop sharing my screen so you can put the Menti up. Does that make sense?
Yep, that's perfect. All right, so we got some great questions here. Okay, so the first question is actually really regarding to COVID, but it goes to a broader question. So, how has COVID impacted the independent monitoring that you've been doing, given all the restrictions because of it? And would a potential solution, which even goes to the broader things we're talking about, greater reliance on cooperative surveys, make data collection more resilient?
I can take that, I guess, or take a start at it. I think our cooperative, some of our independent monitoring on our research vessel surveys this year has been a learning process, as both the vessels and the scientific party have been looking at evaluating and implementing protocols to mitigate the potential for COVID on board a research vessel. So we've been, at this point, we have ended up canceling a number of surveys, but at the same time, we've seen an evolution in some of those protocols that may significantly potentially an alternative methods of executing the surveys that
and be responsive to lapses in coverage for various reasons.
Great. Any other comments on that one? There's two questions, there's at least two on the Bigelow. So one is, can the Bigelow and other large ships be replaced by smaller vessels? And then there's a question about if the risk of the Bigelow collision with the turbine is of concern, are there ways to think about a tug standing by and loss of power or the like? So I think speak a little bit to the Bigelow, which is obviously a key vessel for these things.
I think probably the feasibility of a small vessel would be a little more appealing than the mitigation of a tug standing by, frankly. Again, the advantages of the Bigelow is that it's an extremely efficient method of processing a lot of data. We have a large crew that we're able to bring on. It's like large scientific party, purpose-built fish lab that's extremely efficient, that makes us extremely productive and collect a lot of data. The trade-off with a smaller vessel is access, more maneuverability, and potentially at a bit of a cost to the degree of to the amount of data and the complexity of the data we collect, or we'd end up taking a little bit more time to do that. So yes, it wouldn't, within the wind areas, it may be possible to substitute a smaller vessel as long as we can calibrate the effects of the vessel size and the associated gear on the catch rates.
There was a specific question about the trawl survey, and how does it currently account for untrawlable bottom within a strata? How do you account for hard bottom, shoals, fixed gear, etc.?
We generally will move a station if there's fixed gear that prohibits the occupation of the station, and it's usually within I can't remember the exact protocol radius, and the same thing with untrawlable bottom. We have had a little bit of an advantage on identifying untrawlable bottom with the use of our multi-beam system, so that we can basically scout out the tow path ahead of time and make sure that we have a tow path that has trawlable bottom. If it turns out after a while we can't locate right on the station location, then we look in the immediate area around. So in some cases, it's limited movement of the station to find the next closest set of trawlable bottom.
Great, thank you, Andy.
This is David. I think there's a couple points to be made here. One is the fact that currently you have, random selection by a computer. You won't be able to do that no matter who does the tows. There'll be, fixed stations between the wind array, between the turbines. And so, that's a set of challenges all to itself, because you'll be, you're going to be removing that randomness. And I think, small vessels can do this work, as Wendy stated. It's going to take longer to work up the catch. There's no storage space. There's no, I've done a lot of cooperative research, and you're just working out on deck in a 20 by 20 foot platform. The other question is that these boats have lower profiles. For example, my boat doesn't have paravanes. It only stands 16.5 feet off the water, whereas the Bigelow has got quite a large profile. And there's some question if it could even fit underneath the spinning turbines, as an example, where, boats like us should be able to, work right up close to them because we don't have the height profile. So yeah, there are some considerations here for the use of smaller vessels, and like everything else, it's going to be a trade-off. You're going to gain some things, you're going to lose some others.
Great, thanks, David. The next question is got a lot of votes, so to speak. So it says the percentage area overlap unavailable to survey is one aspect of impact to the survey, but the consequences will also depend on how much of a given stock are in the area of overlap. So have you kind of explored the interaction between these two variables?
Yes, it's species specific. So we've got, for example, our trawl survey is basically everything we catch is monitored and recorded. For commercial and fishery, for managed species, that's a smaller number of species, but it's still significant. I think we're looking at maybe 46 different stock assessments. So the impact of the wind energy area that's unavailable is going to vary depending on how each one of those species uses that habitat. I'd also note that how much of the stock is in that area of overlap may in fact change over the 30-year time frame that these turbines are going to be in place. As Dave Rutter mentioned, we're in a dynamic situation where stock distributions are changing, and the fact that we have one overlap percentage today does not mean that same overlap percentage will persist 30 years.
Great. Wendy, you just cut out there at the end, but I think you captured it, so thank you.
Yeah, I was just going to add an answer to that question. On our first day, we had Kevin Friedland present on a number of research efforts in a recent publication, and so we are beginning to look at this question in some of Kevin Friedland's work. He's probably on right now too, but follow up with him if you have a specific question related to it. Where he's evaluated based on looking backwards with historical data coming out of the bottom trawl survey, some of the stocks and species that have proven to be important in these areas without wind farms. But like Wendy had indicated, that's not necessarily the case moving forward.
Great, thanks, Andy. There's two questions related to this, and I think the short version is, how long will it take NOAA surveying to adapt to the development of wind, and how much will this cost compared to kind of the baseline?
Wendy, have you come back to join us to answer this $67,000 question?
Yeah, I think the answer is more than $67,000.
We're working on it right now.
Yeah, I was going to say, even as we speak, we're trying to come up with some estimates for some alternative approaches, looking at the potential costs of some of those alternative methodologies, either traditional or non-traditional, to figure out ballpark estimate how much that would cost. In terms of adapting to the development, as I said, it's going to be a bit of a process because we're going to have to identify survey modifications. We're going to have to identify and calibrate new methodologies. and then operationalize it. So I think we're planning on trying to come up with our optimal combination in the next year or two, because again, we have to apply this to something like 40 some odd species or 40 some odd stocks. So it may be a multi-year process. That's why, or it certainly will be a multi-year process. The calibration process will depend on the methodologies that we implement. In some cases, we can undertake the calibration and accumulate calibration data as year by year, and then retroactively apply that to original observations. So yeah, I think the scoping and the identification we're looking at, I think probably in the next 2.5 years or so, and then to calibrate and operationalize is going to be probably another. I don't know. I can't guess. It's going to depend on what kind of methods we end up using.
The only thing I would add, thank you, Wendy, and Dave, if you want to, add on to this, the thing I would just add is there are no, we have, some, and we're very grateful for this interagency agreement we have with BOEM to begin to look at this issue, but we have no dedicated available resources to tackle the scale of this problem right now. So there is great risk, sort of taking the Hippocratic oath of, let's, as we think about monitoring and research in wind farms, let's first not harm the current environmental scientific research enterprise that we currently have. We're hoping that we can solve that resource problem, but this is a problem that's solvable. That's the good news. And in solving it could involve great collaboration between the two industries and scientists and our partners that could really help some of the issues that we're having with uncertainty and what the effects are. But it is a resource problem at this point.
Great. We have about 5 minutes left. I want to get a few more in. So this is an interesting question. So could developers implementing NEAMP, state-run lobster surveys, and scallop survey protocols as part of their monitoring plans supplement stock assessment because they're out there collecting data as part of the kind of energy development process?
Wendy, you want to take a crack at it? I mean,
Sure.
My first part of it would be yes, if they're designed to do so. We have resources.
Yeah, I think as long as there's a big scope for that. Again, going back to the original constraints, methodology. If we have some standardized methodology that's consistent from year to year to year, so that we're not looking at method changes over time, and if we have a way to calibrate the developers' programs to provide comparable or to provide data that are scaled to some of our surveys, yes, it is possible. It's going to it really means that has to be part of the objective of the original developer monitoring plans, to be able to integrate the data collected under those monitoring plans from the beginning, rather than as an afterthought. So if people are interested in doing that now, then yes, we have some of that provision for discussions through ROSA and through the development of our revised scallop survey protocols. So yes, as long as it's designed with a standardized approach that is integratable with a robust statistical design, it can be incorporated.
It sounds like getting in there early and coordinating carefully will make that work, and if not, could pose problems for data set comparisons.
I think this is David. I think the operative word here is now. We need to start now. We need, as I said, we need to get in there and do this work of calibrating these various other types of study methods before construction begins. And so the sooner we get started, the better. And if we wait till after constructions begin, you've already closed off areas that can't be looked at. So sooner rather than later should be the operative word.
Thanks, David. Let me get two more questions in if we have time. Is with 40 plus species evaluated using the bottom trawl survey, which vary in their vulnerability to different survey methods, how will you prioritize which species gear surveys to first develop and calibrate?
I think that may be an outcome of the simulation exercise where we compare different methodologies and find the one that does the best job for the greatest number of species. Bear in mind that our existing trawl survey, for example, isn't designed to collect information on some species, but turns out it does a good job of tracking relative abundance rather than an excellent job. So I think right now our trawl survey, again, functions better for some species than others. And I expect that the wind energy area surveys would be in the same situation, that it's impossible to get one single method that does everything well. So this optimization process through this evaluation, through the simulation model, should provide some light on what would be the best combination overall for the greatest number of species.
Right. There is a question which is just related to making sure we don't lose data that could otherwise be useful overall. So surveys described this morning in our first set of presentations were before-after control impact studies or BACI designs, but they won't be easily integrated with stock-wide surveys. So is there any way to rectify this?
Again, this gets back down to, what's the objective of the survey? So if the objective of the survey is within the wind energy area to observe what the effect of wind energy areas are in that wind energy footprint and the immediately adjacent area, that's one objective where you would use a before-after control design, as opposed to something that says over the entire stock range, what's happening and how do we have to change our methodology due to the constraints of wind area operations to maintain that long-term monitoring and distribution abundance. So the design of the sampling depends on the objective, and the BACI design is for one objective, and some of our monitoring designs are for other objectives.
Let me just note, because we want to give people a chance to go to lunch, that there's there are in some ways some offers to help, including potentially, I don't know whether that meant money, but you'll note that in the comments. There's questions about the upcoming workshop and if people can attend, or is there a link? So if people could, maybe put something in the chat about that at lunch, that would be helpful. There is some concern about timing, more statement than question. There are some other kind of interesting questions or comments around some of the other areas that you all covered. Only because of time, we really appreciate this. Again, a lot of good work and a complex system that you've described briefly. Really appreciate it. Panelists, Dave, Wendy, others, thank you for doing it. Really terrific. So our plan is